Hi my dear student friends. Today I am going to explain graph traversal in data structures for second year or first year students for all branches. So today our topic is graph traversal. So already we discussed about graphs and graph terminology and basic elements of a graph and all. So today our topic is graph traversal. So that is nothing but graph traversal is nothing but a technique. It is a technique. This technique is used for searching vertices in a graph. This technique is used for searching vertices in a graph, and also this technique is used for to decide the order of vertices to be visited in the searching process. Okay, na? Generally we are having two types of graph traversal. They are, first one is breadth first search. First traversal is breadth first search, is nothing but BFS. In short, it is called BFS. The second type is depth first search. Depth first search. In short, it is called as DFS. Okay, these are the two types of traversing techniques we are having in graphs. First one is breadth first search, BFS. Second one, depth first search, that is DFS. Okay, so in this I want to explain about first type, that is breadth first search. Okay, the first type is breadth first search. So breadth first search is nothing but level wise order. There is nothing but level wise order. So we want to perform breadth first search. The breadth first search produces the output like spanning tree. It produces the output like spanning tree. Suppose we are taken closed graph. So while performing a BFS traversing technique, it will produce as the output like spanning tree. So what is spanning tree? Without loops in a particular graph. That is the output of a breadth first search. So in generally we want to represent breadth first search. We are using the data structure like Q. We are using Q. So already we know that what is Q. So already we discussed in this previous classes what is Q. So Q depends upon which mechanism? Q depends upon first in first out. First in first out is nothing but what ma? Q is basically depends upon first in first out mechanism. First in first out mechanism. Nothing but first come first serve. First in first out means what ma? First come first serve. Who will come first? They will go outside first. The best example for first in first out or first come first serve mechanism is nothing but ticket reservation booking counter. So which type of booking counter it is not a matter, is a ticket or reservation booking counters. Okay, na queue lines and also queue lines. These are the best example for queue. So who will first enter, they will come out first. That is called first come first serve. So we want to perform depth first search traversing method. We are using the data structure, Q data structure. We are using Q data structure with the maximum size of a total number of vertices in the graph. So maximum size is nothing but, suppose we are taking small graph here. So this is the small tree. So here the maximum size is nothing but, in this tree how many vertices are there, ma? 1, 2, 3, 4, 5, 6, 7. So how total maximum size is what, ma? 7. Size is 7. Size equal to 7. Maximum number of size of total number of vertices in the graph to implement BFS. Breadth first search is nothing but level wise. This one, this way. Level wise. Yes, ma? Level wise it is called breadth first search. So here another point, even most important point, that is all connections at one time. All connections at one time. So all connections means all adjacent or closed nodes to a particular vertices. We need to enqueue and print. We need to enqueue and print. This is all connections at one time. Okay, na? That is main important point. So this is a basic introduction regarding to the graph traversal. That is what is graph traversal, ma? Graph traversal is nothing but a technique. It is used for searching a vertex in a graph. It is used for searching a vertex or vertices in a graph. This technique is also used for decide the order. It is also used for decide the order of vertices to be visited in the process of searching. In the process of searching. How many types of graph traversals are there, ma? There are two types of graph traversals are there. What are those? Breadth first search. First one is breadth first search. So what is the in short we need to call? BFS. Second type, depth first search. In short we can call it as DFS. Okay, now come to the first point. First type, breadth first search. You need to perform the best first search. Okay, now the output of BFS is a spanning tree. So the spanning tree is nothing but what, ma? The graph without loops. A graph without loops. So which data structure we are used to represent the BFS? Queue. We are using queue. What is the queue mechanism? First in, first out, or first come, first serve mechanism. So what is the maximum? It starts with the maximum size. What is the maximum size? How many vertices are there in a particular graph? That is called maximum size of a particular graph. So total number of vertices in a graph. By using this we are going to implement BFS. So here in this BFS we need to consider all connections at one time. All connections at one time. So you have to remember these points of BFS. So now I am going to write a algorithm for BFS. BFS algorithm. So here we are following such kind of algorithm to perform a particular type of techniques. The first point, NQ starting vertex and print that vertex. NQ starting vertex and print that vertex. So second point, while Q is not empty, Q is not empty, then so we need to, when Q is not empty means what ma? First element is go and insert in a particular Q. NQ is nothing but what ma? Insert. In Q we are using two technical words for insertion and deletion. For insertion we are using the word NQ. For deletion we are using the word DQ. So here P is equal to DQ. Again, so in here we are having the small points. P is equal to DQ. Is equal to DQ. So when we can DQ the particular vertices, nothing but which node is going to point, then we can NQ all adjacent unvisited vertices of P. Can NQ, second point, NQ or all unvisited vertices of P. Unvisited vertices of P. NQ means what ma? Print all unvisited vertices of P. So then we can close this. So there's a small algorithm, two-step algorithm we need to follow to perform the breadth first search technique. So here the first point is nothing but NQ starting vertex and print that vertex. So suppose I am taking the small example here. Suppose I am taking this small tree, binary tree for example. So here, so NQ means what ma? Suppose we are following, this is a Q. So how many maximum vertices are there? 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. 7. So this is Q. Then result, print result. Print result. So what is the, here in this technique we need to select any vertex. Means we need to start from any vertex. If they are not mentioned, suppose they are mentioned, it will start from vertex C. Then only we need to start from a particular vertex C. If they are not mentioned, we need to use any vertex. We need to start from any vertex to traverse for searching the BFS. So here I start with the vertex A. I start with the vertex A. So means what ma? NQ starting vertex. NQ means what ma? Insert. NQ means what? Insert. What is the starting vertex? A. When we NQ, automatically and print the vertex. So what is the answer? A. And print the vertex. Then while Q is not empty. Here observe, this is Q. Q is empty? No. Q is not empty. Already we are NQ or we insert the starting vertex A here. So that is not empty. So then Q is not empty. Then we can DQ the particular vertex. So before going to DQ the particular vertex, we have to see what ma? NQ all unvisited vertices of P. So here we can see this is A. So all connected vertices. Already I told in the last point in my theory, all connections at once. So here this is the vertex. So how many closed edges are there? So 2. What are those? B, C. So we need to take both, not one. We need to consider both in either side. Either left side, we can start from a left side or right side. It's not a matter. Okay, any side we need to follow. But both, all connections, all closed connections of a particular vertex, we need to insert or NQ in the particular Q. So then, what are those now? So now P is DQ. So we can DQ the A, means delete from. So what are the adjacents? B, C. B, C. We are inserting here. So then we will go for, what is the next? Already we DQ the A. Next we will go for B. Next we will go for B. So already A is what ma? A is visited. A is already visited. Or it's already DQ. It's visited and DQ. So next B. So what are the adjacent vertices of B? D, E. What are the adjacent vertices of B? D, E. Then we can write B here. Then what are the adjacents? D, E. D, E. Then we can DQ B. Now we are going to C. So what are the C? C is already inserted. Already we are having this what ma? C, D. B, C, D and E also. So what are those? Here what the next one? C. So C contains how many adjacent vertices? 2. What are those? So then we can DQ C. Then C having F, G. So we can write F, G here. So then, next it's move to the D. So then we can, what is D? D doesn't have any adjacent vertices. Means any lived or unvisited vertices. That's why, so we can DQ D, and E also doesn't have any unvisited vertices or allowed vertices. Then we can DQ. And F, it doesn't have any adjacent vertices. Then we can DQ this. Then G, it also doesn't have any unvisited or allowed vertices. So then it will DQ from Q. So this is the answer. What is the answer ma? A, B, C, D, E, F, G. So this is the breadth first search, means level wise, order wise. This is order wise. A, B, C, D, E, F, G. Are you understood ma? This is the small example how we can perform. So first it starts with any vertex. You can start with any vertex. Okay, either left, any vertex means any thing. Either A you can choose, or C you can choose, or we can choose any D, and whatever it may be. And here we can consider all connected edges. We can insert all, we can NQ all connected edges at a time. Okay, now that is the thing. And also this BFS is not having only one way order item. It is having enumerous or now n number of ways. Enumerous means what ma? N number of ways we can print. Here we can observe this one. So here I will start with the root A, same. But here I am considered the adjacent vertices or closed vertices of A is BC. In this example, here I need to consider DCB also. Not only BC, I need to consider CB also. Yes, ma. So again C. C means what, ma? FG. FG means what? G. F also I need to consider. Like this, it will be chain. That is the meaning of it contains n number of ways and numerous ways you need to implement the breadth first search to a particular tree or a graph. Are you understood, ma? So this small algorithm how we can perform that BFS. So now I am taken another example. Here I am taking the graph. Yes, here I am taken this graph. So now I am going to perform BFS for this graph. Breadth first search. So what is the maximum size, ma? N number of vertices or number of vertices. How many vertices? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 number of vertices. So which data structure we are using to perform BFS? Q. We need to follow Q. What is the Q mechanism? First in, first out, or first come, first serve mechanism. Q. Eight. So result. Result of BFS. So what we need to follow? If they are not mentioned starts from a particular node, we need to start from any node. So here I will start with the A. Here according to alphabetical order whatever it may be, I want to start with the vertex A. So here what is the first in the algorithm? What is the first step, ma? NQ starting vertex and print that vertex. So what is our starting vertex? What I choose? A. So NQ means what, ma? Insert that vertex into Q and print in that result. And print in that result. So now we can observe if Q is not, what is the second point? If Q is not empty. Now Q is empty? No. Q is not empty. Then what we can do, ma? So we can DQ the A. We can DQ the A or particular vertex. We can DQ A. Then DQ we can identify the adjacent nodes or closed connection nodes of a particular vertex. What are the closed connection nodes of A? What are the closed vertices of A? B, D, G. B, D, G and G. These are three are the closed edges of a particular node A. So they are not visited. All are unvisited. So we need to bring insert into all connected vertices or all adjacent unvisited vertices. We need to insert or NQ into the Q. So B, G, F. What are those, ma? B, D, G. Now, here, A is already visited. A is already visited. Now, we will go for B. Then, what my next one? B. So, now we can observe what are the adjacent vertices of B. A already visited. No need to consider. Why? We need to write first. A and E, F. A, E, F. A, E, F. So, already A is what, ma? A is already visited. So, it will be strike out. Then, E, F. E, F is what, ma? These two are unvisited adjacent vertices of B. Unvisited adjacent vertices of B. So, then B is visited. So, we can DQ the B. So, B is DQ from Q. Then we can insert this. What are those? E, F. E, F. Then we will go for D. Then we will go for D. What is the next element in Q? D. So, come to the D. Where is D? Here. So, what are the adjacent vertices of D? A and F. A, F. A is already what, ma? Visited. A is already visited. So, no need to consider. Then B. So, while we can DQ. We can DQ D. We can DQ D. So, then already it is A is already visited. No need to consider. Then F is also visited. F is also visited. No need to consider. F is already there in the Q here. So, no need to consider. Next, what is the next element in Q? G. So, G is what, ma? DQ. We can DQ the G. What are the adjacent elements of G? Unvisited elements of G. So, generally, adjacent elements of G is A, E. A, E. A is already visited. A is already visited. E is not visited, but already it is in Q. Already it is in Q. No need to consider. So, then we can DQ G already. Next we will go for E. We will go for E. So, DQ E. So, what are the adjacent vertices of E? E adjacent vertices are B, G. B, G. So, B is already visited. G is already visited. So, no need to consider. B is already visited and G is also visited. So, next go for F, F. So, F we can DQ from Q, F. What are the adjacent unvisited vertices of F? So, what are the total vertices, adjacent vertices of F? C, D, H. In the result, we need to print A, B, D, G, E, F. Next, what are those, ma? So F. What are those? B, C, D, H. B, C, D, H. These are the adjacent vertices of F. So F is DQ from Q. So next, all B. Here you can see B. B is already in the Q as it is visited. No need to consider. C. C is not visited. C is not visited. So we can write here C. So next, D. D is already in the queue. It is visited. Already it is visited. So we can write C here. C here also. Next. What next, ma? D already visited. Next one, H. H is in the queue. No, it is in the queue. So it is unvisited vertex. Then we can insert this H in Q. See, H. So here also we need to insert H. C, H. These two are we need to insert. So yes, ma'am. Next. What is the next one? Then already we are, see, this F is finished. Then we will go for E. So what is E? E is already finished. So F. F is already unvisited. Next we will go for C. So what is C? This is C. So we can DQ C. Here first we can DQ C from Q. Again C. What are the adjacent vertices of C? What are the adjacent vertices of C? F, H. F, H. These two. F. F already visited. F already visited. It is already in the queue. No need to consider. Then what, ma? H. H is also in the queue. No need to. It is already visited. So next, we will go for H. We will go for H. So see this here, H. H means already it is in the queue. It is already visited. So you can see here any adjacent vertices of H. This is a C. H adjacent vertices is what, ma? C. But we are having any, C is already what? Visited in the queue. C is already visited. It is in the queue. No need to consider again. So this is the output. This is the final result of a particular queue. A, B, D, G, E, F, C, H. Yes, ma'am. This is the answer for particular thing. So this is not only one way you need to perform BFS. So we need to perform here. I will start with the A here. My starting node is vertex is A, starting node. But here I will consider what are the adjacent vertices of A? B, D, G. B, D, G. We need to follow either D, B, G here in the order, or we need to follow G, B, D, or we need to follow G, D, B, or also. So number of numerous ways we are having to perform. Not only this order, we need to follow here B, D, G. Here I am following in original, but here we need to follow D, B, G, or G, B, D, or G, D, B. Either way we need to follow, and according to we need to consider in every step. Like this we need to perform numerous or n number of ways we need to perform breadth first search. N number of ways we need to perform breadth first search. So are you understood, ma, how to perform breadth first search? So first we need to insert the starting vertex and print. When we insert into the queue, immediately we can print in the result of BFS. So then we can DQA. While DQA, we need to consider all adjacent unvisited vertices of a particular node. So then we can write in this queue. and automatically we can print in this particular result also. A, B, D, G, E, F, C, H. This is the result. So hope you all understood according to this. So here I will give another graph to you. It's an assignment. You have to all prepare the notes according to this assignment. Exercise, write this exercise all of you. So this is the another graph I am given as an assignment to you. All of you prepare breadth first search according to this graph. Okay, we need to follow Q mechanism. While following Q mechanism, you have to remember the algorithm 2 steps. Then we can follow. Any way, either we can consider the adjacent closed vertices of a particular vertex, either left child or right child. Here we need to consider any vertex, not only initial vertex, not only root, any vertex we have to start. If they are mentioned, we need to start from that vertex or node. If they are not mentioned, anyone we have to choose and traverser and searching for each and every vertex and its order according to its maximum size. Thank you all. I hope understood, my dear students. You have to solve this problem according to this traversal of BFS. Thank you one and all.